morning, everyone. Welcome back to another amazing science tutorial video. I'm Coach Spivey, joined with my son Jordan Spivey, and in this video tutorial, we're going to be going over parallel versus series circuits. So let's get started. First, we want to go ahead and take a look at electric current, and we've looked at it in a previous video, but let's go ahead and take another look at those concepts. And electric current is the continuous flow of electric charge. The unit for electric current is the ampere, and there are two types of electric current. First, we have alternating current, where the flow of electric charge that alternates or switches its flow. So examples of where alternating current would be in your home, an office building, or a school. So let's take a look at an example of that. Notice that in this circuit, the electrical current alternates or switches directions. It goes back and forth. And then if we take a look at direct current, the electric charge flows only in one direction. So for example, we have a flashlight, a TV remote, or a battery operated toy car. And then let's take a look at how the electric charge flows in a direct current. Notice that in a direct current, the electric charge doesn't alternate back and forth. It only travels in one direction, hence the name direct currents. So now let's take a look at circuit diagrams. And these are diagrams that use symbols to represent parts of a circuit, which often include a power source, which is usually a battery, a path for electricity to flow, which is usually within a wire, resistors or a load, which is usually light bulbs or anything that you plug into an electrical outlet, and a switch. And circuit diagrams show the path that electricity can flow. Switches in a circuit diagram show where the circuit can be opened or turned off. An open switch opens a circuit. This stops the flow of electrons, which is what turns off a light in your home. A closed switch closes a circuit, which allows electrons to travel in a full loop, which is what turns on a light in your home. So let's take a look at a couple of these examples below. If you notice right here in this first example on the bottom left, we have a fully closed circuit, which means that electrons and electricity has a full path to flow. So there is no break in this circuit, and that's what ends up turning this light bulb on, because there is no opening in this circuit. That's why they call it closed. But then if you look at an open circuit, here's the point where this circuit has been opened. And that means that these same electrons or the electricity is not able to have a full path to flow, because that path has been stopped right here. And that's what ends up ultimately turning off this light. That's why you call it an open circuit. And if we take a look at this circuit right here, we have our power source, we have our wires for the electrical current to flow, we have our resistor right here with our light bulb, and then we have our switch attached. And this circuit would be considered a closed circuit. And the reason why, because this switch right here is down. So if you have a full path for the electrons to flow, because this switch right here is down, and you have a full path for electrons to flow through this electrical wire or this electrical switch and go right back up to the battery. And that's why this light bulb is turned on. But then if you look at this circuit right here, this light bulb is turned off, and so this would be an open circuit. And what makes it an open circuit is this part right here. If you notice, this switch right here is now down, so that means it's not fully connected to this metal piece right here. That means there's a break in the electrical flow or the flow of electrons. And since there's this break right here, the electrons cannot fully travel through. And that's what turns off that light. So let's look at our next example right here. So when you're at home and you turn off the light switch, you're actually opening that electrical circuit, which is what turns off the light switch, because electrons don't have a full path of flow. When you turn on your light switch, you're actually closing that circuit, because you're giving those electrons a full path of flow, and that's what causes your light switch or your lights to turn on. So now let's take a look at an electrical circuit. And this is a path for electrons being pushed from a voltage to flow. And there are two types of electrical circuits. First, there's a series circuit, which is an electrical circuit where electrical charge has only one path to flow. If one resistor in a series circuit stops working, then it becomes an open circuit. And adding more resistors slows down the current. So for example, if we were to cut this wire right here in this series circuit, that means all these lights would turn off. And the reason why is because the electrons wouldn't have a full path for them to flow. So if you cut it off at one point, then all the other resistors or loads on that circuit are going to cut off, in a series circuit. And as you add more resistors to this circuit, it makes the current go slower and slower. So what you would notice with these light bulbs is that they would get dimmer and dimmer. And now we take a look at our next circuit. We have a parallel circuit, and this electrical circuit is where electrical charge has two or more paths to flow. If one resistor in a parallel circuit stops working, then the other resistors still can operate. And the resistors are wired in parallel so they can operate independently. And so what we mean by this is that if we was to cut this wire right here, the electrons still would have another path to flow. The electrons can still flow to this resistor or to this light bulb, and then to this light bulb as well. Notice that if I cut one wire, that means it does not turn off all the other lights or the other resistors in that circuit. And that's the big difference between a series and a parallel circuit. Let's look at some of the advantages and disadvantages of series and parallel circuits. So some of the advantages for series circuits is that series circuits do not overheat easily. So they're safe around flammable objects. And they're easy to make repairs in, since they're so simple to make. And you can add more power devices and have a higher voltage output. So in a series circuit, you can add more batteries to it to give a higher voltage output. But some disadvantages of a series circuit is that if one part of the circuit breaks, then all parts of that circuit break. So just like the old school light bulbs, if one light bulb went out, that means all the other light bulbs went out because they were wired in series. And then as you add more resistors or loads are added, the more resistance and the less the resistors work. This means that as you add more resistors, the more it slows down the flow of electrical current, and the other resistors may not work as well. And then if we take a look at parallel circuits, some of the advantages of these circuits is that every resistor gets an equal amount of voltage. So every resistor is going to be getting the same amount of voltage, which gives it the opportunity to work equally as properly as the other ones. And then it's easy to connect new materials without affecting the working of other materials. So you can add more resistors to this circuit without impacting or affecting the other resistors. And then if one part of the circuit does not work, then current is able to pass through other parts of the circuit. So if you look at the wiring in your home, if you turn off one light in your home, all of your lights are not going to turn off. It's just that light. Your other lights will still be able to function and operate. But some disadvantages of a parallel circuit is that they require a lot of wires. So since they're parallel, that means we have more than one path for electrons or electricity to flow, which require more wires to be set up. And then it cannot increase or multiply voltage. So you can't add or increase additional voltage to a parallel circuit. And then you cannot pass the same amount of current through each resistor. Parallel circuits will fail in this situation. We've talked a lot about electrical circuits, but now let's talk about electrical safety and how you can keep yourself safe from electricity. And correct insulation, wiring, fuses, circuit breakers, and grounded plugs are all important in making electrical energy safe for us to use in our homes. And most homes in the United States have an average voltage of 120 volts. So everything runs on 120 volts aside from your washer and dryer. Most washer and dryers require 240 volts in order for them to operate. And the more devices that are turned on in a circuit, the more heat there is, which may overheat and start a fire. So that's why they say don't plug up a lot of items on one circuit, or don't plug up a lot of items into an extension cord, because an extension cord can overheat and catch fire. And so one of the main things we use to prevent this overheating is a fuse, which prevents current overload in a circuit by melting a wire if too much current passes through, which inhibits the flow of electricity. This is known as blowing a fuse. So let's take a look at this fuse right here on the right. Notice that this fuse right here is a good fuse. And the way we can tell is because the wire is fully intact and is fully connected. So you have a good amount of electricity going through it. But if we take a look at this, here's a blown fuse. And this right here shows that too much electrical current tried to travel through this fuse. And as a safety valve, this fuse actually broke. So it prevented and stopped the flow of electrons, which caused or prevented the circuit from overheating. And then if we take a look next at a circuit breaker, this is a switch that opens when electrical current in a circuit is too high. You have to reset the circuit switch before it can be used again. So if you notice, here's a circuit breaker right here, and a circuit breaker usually works for different parts of your home. So you usually have a circuit breaker for your car garage, for your kitchen, your living room, or your dining room. And if there's too much electrical current in that circuit, then your circuit breaker switch is tripped. And in order for you to get it to work again, you gotta reset that switch. And then if we take a look at insulation, this is material wrapped around electrical wire, usually rubber, that protects people from touching bare wires and also prevents short circuits. So if you take a look at any wire that you plug into an electrical outlet, you're gonna have some type of protective covering over it, usually rubber or some type of strong or durable plastic. And then lastly, we have grounding, which is the transfer of extra charge through a conductor to earth, which prevents electrical charge from grounding through other objects, which would cause a short circuiting or through you. So if we take a look right here, here's our hot wire right here, and then here's our grounded wire. Notice our grounded wire is actually attached to a grounding rod, which is attached to the earth. So instead of that extra electrical charge being grounded through whatever you have plugged into the wall or being grounded through you, the extra charge actually goes through this grounding wire and goes into this grounding rod and then goes down into the earth where that extra charge can be dispersed. Now it's time for your check for understanding. And you're going to answer the following questions based upon your knowledge of parallel and series circuits. You can go ahead and pause the video now. And ladies and gentlemen, I hope this video tutorial over parallel and series circuits was helpful and beneficial. I hope you got a lot out of it. Once again, I'm Coach Spivey, signing off with my son Jordan Spivey. And make sure you have a wonderful, awesome, positive day. Peace.